wherever you are. Welcome to day 4 of RPKI week. And today we have a
recording in progress.
I guess the recording has started. So anyway, once again, welcome to everybody. And today we have a special guest with us, Alex Band from NLnet Labs. He's a product manager there, and he can probably tell you more about his illustrious career than I can. But we're very excited to hear his presentation today on trust and RPKI and getting yourself started. So with that, Alex, I will turn it over to you. I will be monitoring the chat. So if you have any questions, please feel free, because we'd like this to be as interactive as possible. So with that, Alex, it's yours.
All right. Well, thank you, Karen, and thanks for having me in RPKI week. This is actually quite fun to do. I've been watching all of the presentations earlier in the week, and I was like, oh, it's all panel discussions with more people, and now you're going to have to sort of endure an hour of just little old me. I hope that's okay. Let me see. I would like to share my screen so I can start a presentation. Keynote, share, and then I hit play. There we go. This is about trust in RPKI. It was originally they asked me, can you do like an X.509 Primer? Like, what do you need to know about X.509 in order to start using RPKI? And we did the rounds a little bit, and I guess the answer was not a lot. In fact, we've been trying to sort of abstract all of the cryptography or all of your knowledge of cryptography away from using RPKI. So in order to sort of get started with it, you really don't need to know all that much. And you just don't really need to worry about it. But in order for you to use this system and use it reliably, I guess it's important for you to understand all of the moving parts. And that is what I'd like to spend the next hour on, to sort of explaining the scope of RPKI itself, what your different deployment options are, and what you should take into account. So my name is Alex Band. I work at NLnet Labs and have done for the last 3.5 years already. And in case you're wondering, what do I recognize him from? I have spent 8 years at the RIPE-NCC, where I was responsible for deploying RPKI back in the day. So all the way from 2009, leading up to 2011, when the RIPE-NCC launched it as a production service. I was responsible for that whole trajectory. And after that, for sort of continuing the development of RPKI within the RIPE-NCC. And since the last 3 years, I've been working at NLnet Labs. And then you go like, NLnet Labs, where did I know those guys from? Well, NLnet Labs has been around since 1999. It's a not-for-profit organization making free, open source, liberally licensed software. And we also do research. We're very active within standards development as well. And I guess what you would know us from best is the authoritative DNS server NSD and the DNS recursive resolver Unbound. But that is not what this is about, because 3 years ago, I was like, I have a good idea. Why don't we diversify into, instead of just doing DNS, we also do something in the routing sphere. We've always wanted that, but we never found like a good project. And I was like, I know a couple of missing puzzle pieces in the RPKI jigsaw. And we could develop those, and that would be great, wouldn't it? So this talk is all about the RPKI, and I would like to give you sort of a quick start just to make sure that we're all on the same page. And yeah, again, I've heard a couple of times last week, like, yeah, I'm assuming that you all know what RPKI is, so we don't need to go over that. We can go straight into the deployment. And then I realized there was actually quite some misconceptions and things that were a little bit unclear. And I tried to capture those in this particular presentation. So off we go. I stole this from the APNIC website. I thought that that was actually kind of good because resource certification is a security framework that proves the association between a specific IP address block or AS number and the custodians. I love that word, custodians of those internet number resources. I think I've written a similar sentence before, and instead of the word custodian, I used the legitimate holder. I tried to avoid the word owner because as an RER employee, they keep telling you that you're not the owner of an IP address block. You get to use them. So it's the right to use IP addresses. And that's really what RPKI is all about. It's about the right to use IP resources and AS numbers, and being able to make a testable, authoritative statement about them. So the thing is that this is an X.509 PKI, and what you should really think about and what you should take into account is that people immediately think, oh my God, it's X.509, and they associate it with TLS certificates, and they go, isn't this for sort of identifying who I am? And in fact, it isn't. RPKI was designed using standard X.509 certificates, but the identity part is actually just a hash. Your company information doesn't appear on the certificate at all. You're completely anonymous. It is just the regional internet registry or the person giving you the certificate, giving you the ability to make an authoritative statement about the certificates themselves. But they're not intended to identify who you are. It is just about giving you the permissions to do so. Hang on, I just need to click something. Yeah, we're fine. So basically, you're dealing with 5 regional internet registries, and that's it. You have a contractual relationship with them, and you know these people. You have contact with them at least once a year. I mean, when you pay your bills, for example. So unlike the TLS certificates, where you have this mountain of different certificate authorities that are pre-installed in your browser, pre-installed in your operating system, you have no way of actually knowing who to trust, and you just hoping that the people developing the browser or developing the operating system take good care of making sure that the list of trusted certificate authorities is updated. In this particular case, you're dealing with an entity that you're very, very familiar with. They've all been around since the 90s. They're all openly governed. They're all not-for-profits, and there's a high level of trust within the RER system. And all of this trust, that is what RPKI basically hinges on. So making sure that if you get a certificate and some organization is making an authoritative statement about the resources on that certificate, that you're actually sure that those are the legitimate rightful holders of the IP addresses on the certificate. And it's not given to somebody else who isn't the owner at all. So RPKI isn't specifically designed for routing at all. It is a resource public key infrastructure. It is not about routing. It does have a specific application currently for making internet routing more secure. So everything that we see currently is for using it for root origin validation. So being able to make a statement about the root origination that you as an organization are going to do from your border router. And this should provide a stepping stone to doing fancier things. Currently, what is trying to gain some traction is actually kind of working out within the ITF is, for example, using RPKI as a stepping stone towards autonomous system provider authorization, also known as ASPA, which is more or less path validation light. Doing true BGP-SEC, doing true path validation would, of course, be the holy grail. Because currently you can still spoof the origin within RPKI and then you can circumvent the system. And path validation would plug that hole, but that is actually quite a complex task to implement, because everybody would have to be on board. It is not something you can incrementally deploy like we're doing with root origin validation now. But this is all still in the routing sphere. But what is also been actively worked on right now within the IETF are, for example, resource tagged attestations and resource signed checklists. And these are basically statements, they could be any statement, that are signed with your resources. And I think one of the most practical applications you could think about right now is bring your own IP. And maybe some of you have tried to go through this process with, for example, AWS, where you bring your own IP addresses and have them announced by AWS from their autonomous system number. It's like a whole list. And one of the items in the list that you have to do is publish a ROA, where you authorize the autonomous system of AWS to announce your address space. But the other thing you have to do is provably certify or make a statement that you have an AWS account and this is truly what you wanted. So you basically have to create a text file that contains your AWS account number, and then you have to sign it with a key, and that particular key you have to publish in the Whois database together with your inetnum object. And this is quite a convoluted process and could actually be made a lot easier using a resource tagged attestation that you publish within the RPKI. So there's other applications besides using it for root origin validation and path validation as well. The same goes for resource transfers, where you could basically have a contract that you want to transfer IP addresses from one party to another, and you sign that with your resource certificate stating that these resources are truly that you are truly the holder of these resources and you truly want to transfer them to another party. So making all of that work, there's a couple of moving parts at play here. And currently we're looking at root origin validation, and it basically means that one organization will hold a certificate that contains all of their internet number resources. So that's their IP address blocks and their AES numbers. And using that certificate, they can make an authoritative statement about their intended BGP routing. These are called ROAs, root origin attestations, and other operators, so known as relying parties, can download and verify these ROAs. And then you have all of these ROA objects. And that's another important thing I want to mention. If you have a ROA and it goes through the validation process, then a single signed ROA object can actually encompass multiple IP prefixes, but it always attests to one AS number. So a single ROA can actually have multiple prefixes on them. And then once it goes through the validation process, it actually creates like a plain text list of validated ROA payloads. And these validated ROA payloads are basically single lines of prefix, maximum prefix length, AS number, those three informational elements. So a single signed object can actually encompass like one VRP or maybe even 100. And these 100 VRPs, you compare them to all of the root origins or the announcements that you see on your router. And then you can come up with three possible outcomes: a valid, an invalid, and a not found. So the terminology is somewhat confusing because people talk about valid ROAs or an invalid ROA. So these invalid ROA cause my BGP announcement to be invalid. But that isn't possible at all. Only a valid ROA is basically a signed statement that passed cryptographic validation and then was added to the list of validated payloads. And an invalid ROA, it'll just get rejected and it'll be like the statement was never made. So an invalid ROA can never have any effect on your BGP announcements at all, realistically. So this is why you see like lots of different terminology, like ROAs and validated ROA payloads. Yeah, and the difference basically is that the one is a signed object and the other is the product of the verification process. So keep that in mind. So I've taken an NLnet Labs here as an example, and basically we're dealing with the RIPE NCC, and you go like, wait, what? The RIPE NCC has a root certificate that contains 0/0. What's up with that? So does that mean that they could issue any ROA for any address space, also address space that isn't theirs? Because originally when RPKI was launched in 2011, this wasn't the case at all. The RIPE NCC had a root certificate and all of the other RARs as well that only contained the address space that was allocated to them by IANA. Nothing more, nothing less. So they could only provide child certificates down the tree for resources that they actively managed. But then the whole resource transfer process really started firing up with trading IP addresses and IP addresses changing hands within a regional internet registry. That is all fine. But then when cross RAR transfers started happening, it actually became really complicated to manage with RPKI, because you don't want to end up in a situation where a ROA is being issued for a piece of address space that is actually still managed or still registered by the other RAR. That could lead to that could actually lead to some problems of address space being invalidated or routes being invalidated because of that. So a couple of years ago, they decided to have a 0/0 space and all of the different AS numbers. So over-claiming certificates at all of the RARs. And what you, for example, see at the RIPE NCC is that they have one child certificate of that contains all of the resources that the RAR manages. And from that child certificate, they issue resource certificates to all of their members, who could then in turn distribute certificates to their customers. So we as an NLnet Labs, we have AS number 211321, a couple of IP resources, and with that, we can make another signed statement. So that is basically what they call an end entity certificate that makes a statement about our intended routing. So what we're going to originate. And this is to a large extent comparable to what you see with a route object. Only this is a more reliable route object with a cryptographic signature that can be traced back to the regional internet registry, making the whole system a lot more reliable than it used to be. So this, of course, happens all around the world, with a couple of exceptions in the way that this stuff is managed. Because, for example, in the LACNIC region and the APNIC region, you're dealing with so-called national internet registries as well, where very large chunks of address space are allocated to a national internet registry, who then in turn can issue address space and also certificates for them to their constituents. But this is the certificate authority tree. So this is just the chain of trust that you create with all of the certificates and all of the statements about them. And this is actually completely separate, and this is also something that I want to emphasize, from how you publish them. Because RPKI publication is actually completely disconnected from the certificate authority tree. So you're completely free to set up a CA structure and then make a choice where you want to publish these things. So this is why you see, even though there are currently thousands of organizations who run RPKI, you see currently up to 30 different publication points that relying party software connects to and fetches information from. And these 30 different publication points that you see, they can contain ROAs for the organization that actually runs that CA, but they could also contain ROAs from another organization. And that's all fine, because as long as all of these statements and these certificates can be traced back up the tree to the RER who issued the resources, it's all fine. It doesn't really matter where things are published. And it also doesn't really matter how they are transported. So currently there are even 2 transport methods from a publication point to relying party software. Originally, we were all using rsync to distribute RPKI data, and nowadays virtually everybody is using the so-called RRDP protocol. So that is a protocol that relies on deltas and using HTTPS to distribute the data, which in the end makes it more efficient to get everything down to relying parties. So you'll see a lot of different publication points, and again, it doesn't really matter which ROAs are being published in it, because ultimately the trust comes from the certificate chain and not from the transport method or where the objects are stored. So at the end of the day, I think RPKI was originally designed with the idea in mind that everybody would run their own certificate authority software. So you would have your own private and public key pair, you would sign it, it would be signed by the parent certificate authority, and then you would publish all of your cryptographic material yourself, or you would outsource that to a third party. But then, and I was involved in these discussions as well, learning from, for example, DNSSEC deployment, where I did DNSSEC training, and I was explaining to people how to sign their zone with DNSSEC. And this was in a time that even the root wasn't signed yet. And then people were like, oh my God, I have to do all of this effort in order to sign my zone. And then if I make a mistake, then I make my entire zone unavailable, and I cannot rely on any of the other parts in the chain. I'm just creating my own little secure island. Why would I go through all of this effort for the gain that I'm getting here? So also with RPKI, we were like, we really need to try to skip a lot of these steps in order to make it more accessible to people, in order to get across that first hurdle of deployment, where it's easy to set up a certificate, it's easy to publish a ROA, and you're not dealing with all of the crypto infrastructure yourself. So with hosted RPKI, you basically take that burden away, but that actually comes at a cost. You log into some web portal, you say, I want a certificate, and basically a private and public key pair is generated and lives on a server that the RER hosts. So you have to trust them to do this, and you have to trust them to do this well, to manage this well and have like a good certification policy of key roles and key lengths and all of that. But as long as that is clearly documented and available for everybody to review, and people are okay with the process that is in place, it's actually a really good way to get started with RPKI and to use that. And I think it applies to almost, the vast majority, 90+% of organizations. Hosted RPKI is absolutely fine to use. It's an easy way to get started, and you don't really have to worry about a thing. All of the keys, the signed products, they're kept and published in the RER infrastructure. You can just go for it. But of course, running delegated RPKI, you can generate your own signed products, and you can publish them yourself or let a third party do it. So like I said, we went through these discussions, and then all of the RERs have been offering hosted RPKI since 2011. You can use the web portal, and in most cases, the regional internet registries also offer an API you can talk to. But that's where the comparisons sort of stop. The implementations that all of the RERs have are vastly, vastly different. And I think for a lot of people that just have address space within their own regional, within their own region, and they have never been exposed to the web portal that the other RER offers, they think, well, that is my reality and that's how it works. But some of the systems, for example, when you create a ROA, before you publish it, it'll actually tell you this is the effect that it's going to have on the BGP announcements that are seen by all of the root collectors around the world. So it'll make all of these announcements valid and potentially make these ones invalid. Are you sure you want to do this? Giving you the confidence to sort of roll that out and use the system and know what you're getting into. Some of the systems, for example, have alerting that if the root collectors see an announcement that isn't covered by a ROA, it would send you an email. If something goes from valid to invalid because of a hijack or because of a misconfigured ROA, you would also get an alert. And for example, APNIC has a system where it automatically creates matching root objects in the IRR together with creating the ROA. So it keeps those two in sync, making management even easier. So the functional differences across the 5 RARs are actually quite big. And I think what you see is a trend that a lot of them try to abstract all of the cryptography away from you. Which is sort of coming back to what I said initially about what you would have to know about all of the cryptography and for example, the lifetimes and do I need to make a call about how long I want this ROA to live, and then do give it a lifetime of 6 months, or do I give it a lifetime of 1 year, and then when do I go back into this portal and create a new object? Pretty soon, especially at the RIPE-NCC, and I think also APNIC and LACNIC, I think we all thought, well, people don't really need to worry about this. What they really need to worry about is authorizing their BGP origins. So they simply get a list of all of the BGP announcements that are being seen, and they have to make a decision which ones are authorized and which ones are not. And then renewal of the cryptographic object that goes with that authorization that you selected within that web portal is then automatically published, and it is also automatically renewed. You don't have to worry about any of this, which actually makes it I think kind of useful, because like I said, the cryptography aspect of it is completely abstracted away. And you don't have to know about all of the machinery that goes on behind the RPKI system itself. It's basically a mechanism to make it work. So with hosted RPKI, you have nothing to worry about with regards to hardware operations, key storage, publication. You don't have no worries about uptime or availability. The only point where that becomes a problem, for example, is if you need to log into the web portal of the RAR and it is unavailable because of an outage or because of maintenance, and you urgently need to change the ROA, but you can't. That's when it becomes annoying. Yeah, and like I said, it's a great way to get some operational experience with the system, and you basically have nothing to manage. So this is how it looks for the RIPE-NCC. Hosted RPKI is really super simple, and that is, for example, a system that relies on root collector information, shows you all of the announcements that are being done with your prefixes. You basically have to say, okay, this is what's authorized, publish that, see a preview of how that will affect the RPKI validity of your routes. And then if you're happy with the result, you can go and publish it. And all of these objects, they will be renewed and it will stay active and live within the system for as long as you keep the authorization there. And even the API, it works like that. So within the API, you don't get to directly change ROAs. You basically make a statement of what you want authorized. And again, also via the API, the associated cryptographic object is automatically generated and created. So sometimes if you look at graphs of RPKI uptake, you see amount of ROAs created. But that is actually not really a fair assessment of how many routes are validated or how much of the address space is covered. Because you can create one cryptographic object for each BGP announcement, or you could create one ROA object that covers 100 announcements. It's basically up to you to make a decision on how you want to do that. So if you really want to count properly, you should count validated ROA prefixes. So what is ultimately the result of that single ROA. But then, of course, you have the ability to revoke your hosted CA and go like, no, I want to take matters into my own hands, and I want to run delegated RPKI. This is what the dialog looks like for the RIPE NCC. It didn't exist. Didn't exist before. I think it was introduced in the last year or so, and I had to include a screenshot of it because I think it's great. It's 4 check marks, and you have to type your registration ID, and you have to type revoke in capitals. Are you absolutely sure that this is what you want to do? So once you go here, there's absolutely no question that this is what we're going to do. And then you can take matters into your own hands and go for it. So running delegated RPKI. Now, with everything that I just told you, you may be left wondering, like, why would I even want this? What is the point? This hosted RPKI is perfect. Well, with delegated RPKI, of course, you host and maintain all of the software yourself. You generate your own certificate, and you have it signed by the parent CA. You publish all of these objects yourself, so you have to set up your own publication server with an rsync endpoint, with an HTTPS endpoint, or you can ask a third party to do this for you. It's not a problem, like I said, where you publish all of these objects, because when relying party software, it connects to the trust anchor, so it fetches the root certificate of the regional internet registry, and then every certificate will has like a little pointer to all of their child certificates. So it'll follow the tree down and find all of the information that is being published automatically. It's not something that you have to worry about. And then, yeah, there could be a couple of really good reasons to do this. And I think the most important one is with regards to management. So especially if you're a larger organization, you have address space in multiple regions, you're basically dealing with multiple credentials, maybe 2-factor authentication, yes or no, maybe a BPKI certificate for like a browser certificate to log into the system or not. You're dealing with different islands of managing your authorizations instead of being able to merge it all into a single place. So if you have address space in multiple RER regions, having delegated RPKI and being able to manage everything under one roof could actually be kind of useful. Also, if you're a larger organization and you would like to distribute management of ROAS to different entities, like different global business units of divisions of your organization, or maybe even customers that you would like to delegate RPKI management to, that is a possibility. Right now, within hosted RPKI, you're basically in a situation where you, as the parent organization, all of the resources that are on your certificate, you have to manage ROAS for them. Also, if they are your customers. And that could be annoying. And there's no way to sort of chop this up and make different entities responsible for their own little island of address space that they manage themselves. And that is one of the most important reasons. So having address space across regions and the ability to delegate to different entities or customers to run delegated RPKI. But it comes with then a couple of other advantages as well, because all of your ROA management, instead of having to talk to like 5 different APIs of 5 different regional internet registry implementations, you basically have one API you can talk to. And of course, you can hook everything up into your local alerting system. So if you have Prometheus or Zabbix or something like that, you could just have hooks into it. That say, if one of my routes turns RPKI invalid, I want an alert to go off here. With most of the hosted RPKI systems of the RERs, you're basically, you're getting an email that is maybe sent to your NOC, and then you have to deal with that in that way. So you can streamline your management a lot. And you can automate a lot as well, where you basically, if you do a new announcement on your router, then you can have your delegated RPKI system automatically issue a ROA for it. And then, for the security conscious amongst you, of course, you're also the only one who's in possession of their private key. So you think, oh, okay, Alex, that's a pretty compelling argument. So what if I choose this? And what's involved here? Well, what kind of setup I'm going to need in terms of like software, hardware, and services and everything? Yeah, so you're not dealing with a whole lot of cryptography. Basically, if a root origin authorization is published, then the way the system works is that as long as that ROA is there and it's published, it's re-signed once every 24 hours. So if it's older than 24 hours, so it hasn't been re-signed within that time frame, then relying party software will actually reject your ROA. It'll throw it on the floor like it doesn't exist. So you have to keep your system running, but it's not like it has to run 24/7 all the time. If you take your certificate authority software down for like an hour or two in order to run maintenance, then basically you lose the ability to create or edit or manage ROAs. But everything that is being published on your publication server at your publication point, that is actually a separate component and is served to the world, it's all fine. So there's no strict uptime requirement for the certificate authority itself. And yeah, in most cases, if you secure the system well, then having all of the keys on disk is fine. And yeah, if you want to store it on an HSM, then really that is a then that is a possibility as well. So with regards to publication, of course, you can set up an HTTPS and rsync server yourself that serves the ROA files to the world to make it available to relying party software. But nowadays, there's also the ability to outsource it. So currently, that is a service that's being offered by APNIC and the National Internet Registry of Brazil, NICBR. But several other RERs also have this on their roadmap. It is something that has also been requested, for example, from Aaron and the RIPE-NCC. And I know that this is something that they actively have on their roadmap and that they're working on to also offer. So with that, you would really only have to worry about installing the certificate authority software. And then you can just publish with a third party, and that actually makes life a whole lot easier for you. Yeah, and this is the bit where I talk a bit about the software that we make ourselves, but not a whole lot because, it is not a commercial. But in addition to the relying party software Routinator that we make, we also make Krill. And this is a single screenshot of it. Basically, it has a lot of the components that the RIPE-NCC system has. Purely because, we spent a couple of years making it. And then, when you remake something, then you take all of the good ideas. So also here, it uses root collector information to get an overview of all of the resources that are on your certificate and basically tells you, this is the RPKI validity state, and this is what you could authorize. And you just have to say, okay, this is authorized. And then again, the system will just generate a certificate. Generate a ROA and publish it for you, basically immediately. We thought this was a bit of a niche when we developed it, but then this happened, and I still need to update that. This is all the numbers up to March, but it's well over 700 organizations that now run Krill across the world at various shapes and sizes. So also the National Internet Registry of Brazil, NICBR, and for example, the National Internet Registry of Indonesia, so IDNIC, they all run Krill also to offer a service to their members. So it's used from regional internet registries to national internet registries to large operators to really small operators. Especially in Brazil, where they don't offer hosted RPKI, this is really like a thing that has taken off. So do you choose hosted or delegated RPKI? Well, I think the most important thing I want to say about this, and this come across, I've seen this sentiment and this advice several times this week, and I have to repeat it because it's the most important thing. It's better to create no ROAS than bad ones. Once you start creating ROAS, you have to maintain them. Because if you change your BGP announcements, but you forget to update your ROAS, you will turn things invalid. And nowadays that will have consequences on your reliability. So, and on your availability, I mean. So you have to make sure that you make RPKI a part of your standard operations. Make sure that you set up monitoring, alerting. Make sure that you train your first line help desk, especially when people contact you and they say, hey, I cannot reach you anymore, or I can't be reached. What is happening? And your help desk is digging and digging and digging, and they can't find the reason why, but they never thought that an incorrect ROA could actually be the cause. It can cause you so much pain and trouble. So make sure that you train people and roll this out throughout the organizations. And that everybody knows that you're doing RPKI and that creating ROAS has actual consequences. Yeah, and about delegated RPKI, look, if you're trying to disconnect yourself from the regional internet registry, go like, oh, then I run my own CA, and then I'm in charge of my own operations, and I have my own certificate, and it'll give me freedom and liberty. It doesn't work like that. So the RER signed your certificate, and they can take that signature away. It is as easy as that. If they revoke it, it's done. If they remove resources from your registered holdership, then you lose them from your certificate, and you can no longer issue ROAS for it. That's as simple as it is. So don't do it because of that. That's not a good reason. Yeah, and is it more convenient? That really depends on your use case. So how many prefixes do you manage across the globe? How often do they change? How badly are you dealing with an API? How much can you automate? And in some of these cases, running delegated RPKI could actually be a choice that you make. And this is also a common misconception that I want to emphasize. What if it breaks? Well, if all of your ROAS disappear, then all of your BGP announcements go back to the unknown state. Your BGP announcements will not be RPKI invalid if your ROAS disappear. Yeah, it's a comparison that people tend to make from what they know from DNSSEC. Like, oh no, if I mess it up, then I make my zone unavailable. But it doesn't work like that. It is a positive statement on routing intent. So if you lose your keys, you have a complete hardware failure. If your CA goes down, in most cases, you have hours to fix it, to roll over to a backup system and just go for it again. And that also goes for like hosted RPKI that the RERs offer. So if, for example, the web portal to manage ROAS is down, yeah, you cannot make any changes. But as long as your ROA objects about what is currently valid is being served by the publication servers, it's all fine. Reliant party software doesn't notice. And ultimately, if everything breaks, then all routes will eventually fall back to the now not found state, basically as if RPKI were never used. And this is where really you make a difference. And this is why ROA management is so critically important. Because over the last year, dropping invalids is like a really big thing. If you look at this list of operators that I got from RPKI.exposed, this is just a couple of examples, but this list is actually very long. And with so many tier 1s now also dropping invalids, if you mess up your ROAS, it will have consequences. So make sure that you monitor them, make sure that you manage them. And this is also where I do a shout out to Massimo Candela for BGP Alerter. It's really good software for monitoring these kinds of things. So install that and use that. It's really good. And that's sort of it. That's what I wanted to tell you. And for the rest, I hope we can do some interactive shit where I answer some of your questions. Yeah, if you want to know more about RPKI, I spent a long time writing rpki.readthedocs.io that I maintain religiously every day, making sure it's up to date with how RPKI works, what all of the latest software is that you can use, useful presentations, operational experiences. I try to gather everything there. Yeah, I'm happy to accept pull requests. It's all open source and available to everybody. The software that we develop is available on our GitHub website. Yeah, we offer a mailing list. There's Twitter accounts, and yeah, I want to draw your attention to the Discord server that we have for the community. In addition to the mailing list, we thought, you know, from my experiences with programming languages like Rust, I saw that there was like a really vibrant community on Discord. And then I figured, let me try that out. And now we have almost 300 members on the Discord server discussing RPKI operations on a daily basis. So that turned out to sort of explode and be really popular. I don't have a vanity URL for it. So if you go to GitHub or if you go to our website, just look for this particular button, RPKI on Discord, just click it and you'll find the invite. And that's sort of it. That's what I wanted to tell you. Are there any questions? Let me click stop sharing. There we go.
Thanks, Alex. That was very helpful. The one question that I've already seen was related to tools, and Max had already pointed out the BGP alerter as a tool that folks need to be using. Is there anything else that you wanted to say about monitoring or alarm processes? I guess Daniel was typing a question about, you know, implementing it seems straightforward enough, but the part that really seems a little bit more tenuous is the monitoring and alarming.
Yeah, I think, yeah, I really only personally have experience with BGP Alerter because it does everything that we need, and I think it's really great. And I can't really think of any other examples off the top of my head. We're trying to work on some monitoring ourselves, but that is really, that is currently still a little bit experimental, and we're trying to turn that into a production service. Because I think with when the RIPE-NCC validator was discontinued, I think the functionality that people missed the most was a so-called BGP preview. So people create a ROA within whatever interface they make, and then they want to see whether it's actually published and has the desired effect in the real world. So they go to their relying party software, go to their BGP preview, and then type in their prefix, and they see, see, that's my announcement, and this is the validity state that it has. And now that that functionality has disappeared, we're in the process of replicating that. So currently a preview is available on routenator.nlnetlabs.nl, where you can try this out and give us some feedback. We're trying to turn this into not just a user interface, but also a public API that people can use. Yeah, and for the rest, I think PM-ACCT, so PMACT, is also really good software to have a look at, so that the potential outcome of your ROAS on RPKI validity. So also if you would go through the process of dropping RPKI invalids, that's actually a really good tool to have a look at what the effects are going to be if you're going to do that. All right, anyone else?
I just note that Max has again sent the message on BGP Alerter. I believe I saw him send it earlier in the week as well. So he's clearly a big fan of that tool, as are you.
So the question from Antoine Verschuren is basically where the PM-ACCT comes in, like Max mentions in the chat. Yeah. Okay. All right.
Excellent. So we have 8 minutes left. Are there any other questions before we get to the polling for the?
Are you telling me I stayed within the time?
I am, yes. And you've left enough. You've left enough time for us to do our quiz at the end within the hour time frame, which is fantastic. I put this in the chat earlier, but the slides will be available on the web page afterwards. So that would be great. Thank you very much, Alex.
Cheers.
Oh, Max is saying that those tools were both written by fellow Italians. Oh, wait, there's another quick question here, AppTab.
Hey, sometimes we see unsafe ROAS, yeah. So I have a good idea. So let me just pull up the documentation and put a link in here. I put a link in the chat, and because that has the complete. Now I want to send it to the panelists and the attendees. There we go. So unsafe VRPs. So sometimes if your address space of a VRP overlaps with resources from a CA that has been rejected, then this validated row prefix is said to be unsafe. Because you're not entirely sure whether it is going to be valid or invalid. It could flag a legitimate route as RPKI invalid. It's something. It's a scenario that we thought of that needed some attention, but we're not entirely sure whether we should be dropping these. So currently, it is just a warning telling you that this happened. And it is basically your decision whether you want to do anything about it. For us, we haven't quite determined. We're still looking for operator feedback, what we should be doing with these kinds of situations. It sometimes happens, especially when people sort of turn off their certificate authority and leave ROAS to sort of go stale. And they may be overlapping with other resources. You get like a state where you're not entirely sure what to do with it. So another question is, do you plan to add HTTPS to Routinator? Yes, that is on the list of things that we would like to do. But to be perfectly honest with you, Jersey, what we do ourselves and what we see most of the operators around us do is that they just run like a reverse proxy in front of Routinator. So for example, Nginx or something like that, where you forward all of the traffic to Routinator, just serving HTTP only, because the TLS certificate management in products like Nginx is just a lot more mature than us sort of trying to rebuild that ourselves. I mean, it's so easy to set up Nginx and certbot and just have that managed, and then reverse proxy everything to Routinator's HTTP port. So it's a very cheap way of getting the functionality. But you know, since requests are trickling in, we're going to have a look at whether we can do that natively anyway. Yeah. See, there we go.
Did you? I retyped a question from AFTAB that we missed earlier on the Aaron's activity, the removal of their towel.
Is Aaron going to remove their towel? What? So there's a couple of situations with Aaron. Of course, there's their relying party agreement. But basically, you have to read some legal documentation with regards to indemnification of Aaron. So if your network becomes unreachable and you think that it's Aaron's fault, then basically you indemnify them. And you can't hold Aaron liable for that. So you have to agree to that before you're allowed to use their towel. Yeah, it's a thing. It's I mean, many presentations at Nanook have been given about it. from legal people to operators. Currently I have the feeling that operators are kind of okay with the current status quo. That it is just an agreement that you have to go through, and it's all fine. I have the impression that currently it's like scrolling through the terms and conditions of using a online service and finding the yes, I accept button and then continuing with the rest of your life. I know it's a lot more nuanced than that, and we can have a really long discussion about it, but I don't think this is the forum to do that. People can take that up with John Curran and have lots of fun with it. Let me see also, Aaron on the 20th has an outage planned. I asked a lot of questions. I did. I asked a lot of questions on the Aaron forum. I was like, what are you going to do? Because I noticed that the expiration date of their CRL and their manifest was exactly on the date that they were going to do this outage, this sort of fire drill. I was like, are you purposely going to break the RPKI infrastructure so to make everything invalid, to make everything disappear? And then they said, no, we're not going to do that. So they explicitly said they're not going to tamper with any objects. They're just going to make the HTTP and rsync endpoints unavailable for 30 minutes. If that is truly how this goes down, then you should not notice this at all. Because when relying party software cannot reach the publication point, then they're like, oh no, I can't reach it. Well, then I'll just use my cache data and try again the next time. So it'll do this 3 times with, for example, Routinator having a 10-minute update interval. It was like, oh, I can't reach it. Let me use my cache data. Oh, I can't reach it. And does that a couple of times. And then it can reach it again, and then it'll continue life as normal. So if that is truly what Aaron is going to do, disable their HTTPS and rsync endpoints for 30 minutes, you shouldn't notice. There we go. I think it's possible to add your own VRP to Routinator. Yes, there's a standard for it. It is called Slurm. And now I forget what that stands for, but maybe I can look it up real quick.
Yeah, Amrish has already posted a link.
Yeah. Simplified local internet number resource management with RPKI. Jesus Christ, how did I come up with that? There we go. So yes, that's the one. Thank you. You're so good. Yeah, sorry. I pasted it and then you're quicker than me. So that is how to do it. It's basically a little JSON file, and you can edit this on the fly. So while it's running, so every time there's a validation run going, it'll read that file and add these local exceptions. So one practical thing that you can think of is actually a fun scenario that is also described in the FAQ on rpki.readthedocs.io. What if the RIR inadvertently publishes incorrect ROA for their publication point? So for the prefix in which the RPKI publication point resides, because that would make their RPKI repository completely unavailable. There's actually a little template out there to always make sure that these repositories are valid for the extreme corner case that would happen. There's if the RER fat fingers and they inadvertently create an incorrect ROA for their own RPKI repository, that would be really odd. But could theoretically happen, and there's actually nothing you can do to mitigate it. You would basically have to, everything becomes unavailable. So you would have to wait until everything expires, everything falls back to unknown, and then you can reach it again, and then life should be okay. But then that'll cause some pain and hurt for like 24 hours. Yeah. Anyone else? This is fun. So many questions.
Excellent. Well, now you have used all your time. So
okay.
So with that, I think we will, Amresh, are you ready to do your polling?
Yes, I'm ready. Hey, Alex.
Hey, Amrish, good to see you.
Good to see you too. Yeah, I would really recommend people to go on RPKI, read the docs for me. It has become the Bible. So I refer to it every time. So I know the in and out. So a very good job, Alex.
No, thank you.
Yeah, so it's question time. And I hope we will get winners for t-shirts. I will, of course, not allow panelists to vote because that would be cheating. Let me launch the poll now. So after ROV, root origin validation, each BGP announcement can have one of these three states. Please vote. I'll give you a couple of seconds. Wow, only good responses. Nice.
You should have more difficult questions.
Yeah. Oh, a few wrong answers coming in. Let them come in. There we go. So the right answer, of course, is valid, invalid, and not found. We also call it unknown sometimes. Let me share the results. There you go. And we move to the next question. Now, all right. In the RPKI delegated mode, who generates and manages the private key? Is it the RIO, the LIO, or both of them?
This is where we need more of that music, Alex.
Yeah.
Yeah, exactly.
I'm ending the poll now.
It should have like suspense music, right?
Yeah.
Yeah. And the result, of course, is the LIO as the one to which space was delegated, and you run a delegated, then you manage your own private key. Right. Third question, third and last. If you follow this webinar, it should be very easy. Which NLnet lab tool can be used to operate a delegated RPKI? Aha, I see a lot of wrong responses.
I'm further choosing unbound.
All right, let us share the results. Of course, it's Krill. Yay. Good job, everyone. And my colleagues Aftab and Adrian will choose the winners randomly, and we'll send out t-shirts. Thank you very much.
All right answers, excellently. Paid attention. So with that, as Aftab has put in the chat, don't forget the ROA contest, and there's a link to that. And we have one more day of our RPKI week activities, and thank you everybody for attending.